Hey guys, Andrew Buckner here again. Welcome back. Hope you guys are having a great start to the new year. Today what we're going to be doing is solving for another function here when we're asked to take the derivative. So the problem's asking us to solve for the sine of x squared plus 3, and again we're being asked to take the derivative of it. I'm going to then rewrite this in my way that's showing that we're taking the derivative with respect to x of the same function here. However, one thing I'm going to notice is, unlike some of the other problems, I have a function within another function here. So I've got an inner function, which is my binomial x squared plus 3, and then my outer function, which is sine. And I'm not really sure how to do that. But we have another rule. It's called the chain rule, where two things are linked together like this in a chain. So in order for us to understand the chain rule, what we do is, again, I'm going to write this out so we can explicitly see what we're doing. So I'm going to have my outer function be this f, and then my inner function be this g of x. And again, I'm being asked to take the derivative of it. So what the chain rule does for us is it allows us to then make our lives easier. So what it states is I'm going to take the derivative of the outer function, which I'm going to represent as a prime again, multiplied by the inner function here, g of x. That doesn't just stop there. I have to then deal with the inner function as well. So what I'm going to do is then multiply it by the inner function, g of x, but I'm taking the derivative of that there in that instance. So I'm going to rewrite this now in this way. So I'm going to have my sine x squared plus 3, but I'm denoting that as a prime because I'm taking the derivative of that. And then I'm also then multiplying it by the inner function x squared plus 3, and I'm taking the derivative of that. One of the things that we want to make sure that we're doing is understanding, again, like before, that when I'm taking the derivative of a function and two things are added together, I treat them separately. So in our case here, which let me go back to the pink here to keep things consistent again, is I'm going to have my power rule again. I'm going to have my derivative of a constant, but then I'm also going to have my derivative of a trig function here, which in our case, I'm just going to have it be x. So we'll just put sine x just to make things easier. So we're going to start with the power rule. Sorry, the pen's running out of ink a little bit. The power rule states again that I've got my original function here, but when I'm taking the derivative of it, I subtract 1 from the exponential, but then my original exponent value comes down in front, multiplying together. Like we stated before in other videos, that the derivative of a constant is going to be 0. However, with this last case here, what we see is I'm going to be getting something completely different. And what we get here is I get a cosine of x. We'll be explaining later why that's significant in a way. But for our purpose here, I'm going to take each one of these rules and go over here and see it. So I'm going to take the derivative of the outer function here, which we just saw as cosine. So my sine becomes a cosine, but I'm also leaving the inner function constant here. Now I'm multiplying this by two things. So when we take the derivative of a 3, like we said here, because it's a constant, for the 4, it's 0. But then I need to do the power rule here, which is why I stated up before. So I'm just going to get 2x there, which is my final answer. If you want to clean it up, you don't have to. It just looks a little nicer. You can bring the 2 in front or the 2x out in front, depending on how you enjoy looking at a problem. I prefer the 2 out in front here. So my answer will look like this, or a 2 multiplied by the cosine of x squared plus 3, all multiplied by an x out behind it, which they are both correct. Again, one thing to be sure is that you're watching your signs here, because eventually what you're going to get into is if this is a cosine, this will not just be a sine, which we'll go over in another video. But thanks guys so much for watching, and I'll see you in the next video.